The diagram shows the probability distribution for the continuous random variable x, where x is normally distributed with a mean mu and variance of sigma squared, or standard deviation sigma. The distribution is symmetrical about the line x is equal to 20, and there is a point of inflection at x is equal to 15. 60 independent readings of x are made. Calculate the probability at least 40 of these readings are between 16 and 24. Now the problem is we've got a normal distribution and we don't know its mean and standard deviation, but we've got some information over here which will help us find that. So, writing down the parameters of a normal distribution, they are the mean and the variance. The variance is the standard deviation squared. So the mu is actually going to be the line of symmetry, which is at 20. And a good point here to remember, the points of inflection are one standard deviation away from the mean, which means our standard deviation in this case is going to be 20 minus 15, which is 5. So the points of inflection will be at this point here and then also at 25. We don't need to know that, but we do need to know that that will give us a standard deviation. So the parameters of my normal distribution, or this normal distribution, are going to be 20 and 5 squared. First of all, we've got to calculate the probability of being between 16 and 24. Now, you can use some graphing calculator or some other aid. I'm going to use GeoGebra. So when I open GeoGebra, we get this. You have to go to the view. This is classic 5 GeoGebra, and you have to go to the probability calculator, and I'm going to enlarge it. And a little thing, because I'm using a Mac, you need to normally raise this up. Okay, so want the normal, it's normal mean 20 and standard deviation 5, which gives me that. I'm going to have to raise it up a little bit more in order to see what I've got here, and I want P being between 16 and 24. Let's work that out. Okay, so we get an answer of 0.5763 from the calculator or whatever aid you're using. So going back to this, we're going to get 0.5763. Now, we want at least 40 of these independent readings are between 16 and 24. So in order to do that, we need to set up a binomial distribution. So let y be the random variable of the number of readings between 16 and 24 in 60 independent readings. So y will be binomially distributed with np. So y will be binomially distributed with an n of 60 and a p of 0.5763. Okay, and we want, this is the probability of success for this particular problem, and therefore we require the probability of at least 40. So we want the probability that y is greater or equal to 40. So again, going to whatever graphing calculator, I'm going to use GeoGebra. I'm just going to change here now the distribution to a binomial one. Okay, and n is going to be changed to 60, and my probability of success is going to be 0.5763. Okay, and then I want x to be greater than or equal to 40. So change that 36 to 40. Okay, and then I get an answer of 0.0982. So from that gives me an answer of 0.0982. So this has been a video to show you how to use a normal distribution in order to calculate a binomial probability. I hope you've understood, and I thank you very much for watching.